Alright, the first question we are going to be looking at is, we have the expression 5 raised to power 2 times 5 raised to power 3. What will be the answer to this? Now, from the rules of indices, we said a raised to power m times a raised to power n will be equal to a raised to power m plus n. You pick one of the bases, they are the same, then you add up the powers. That is all. So now, since this and this are the same thing, and it's multiplication, not addition or subtraction or division, though. It should be multiplication, and both of them should be the same in bases. The power may not be the same, no problem. So you pick one of the bases, then you add up the power. 2 plus what? Plus 3. So this will give us 5 raised to power 5. That's the answer to that. Then question 2. Question is 3 raised to power 2 divided by 3 raised to power 2 times 3 raised to power 4. Now, if this is a division sign, not a multiplication, the same thing still apply though. But if it's not a division sign, not multiplication, then this sign will change to negative, change to minus or subtraction. If it's multiplication, if this is multiplication, it will be addition here. If it's division, it will be subtraction here. Take note. So what I'm going to do now, let me try and follow BODMAS. I will do division first from BODMAS. It's division before multiplication. So I'm going to have 3 raised to power 2. Since it's division, the bases are the same. I'll pick one of the base and subtract the power. Then times 3 raised to power 4. So that this will give us something very nice. That is 3 raised to power 2 minus 2. That will be 0 times 3 raised to power 4. So next, look at this. The two bases are still the same. Then this one is now multiplication. So I'll still pick one of the bases. Then I will just add up the power 0 plus 4. So this will give us 3 raised to power 4 answer. So please take note of that, or 81. So let's look at other questions. So we're having 9 over 6 raised to power half. So I'm going to do this. So to do this, you check out this base here. In that power, check out the denominator. That denominator there. Then ensure you will look for a number. This is 9 over 16. Please take note of that. Ensure you look for a number that you will raise to the power of this denominator. And the answer will be this. And the answer will also be this. So which number is that? If I raise 3 to the power of this denominator, I'm going to have 9. That is 3 squared. If I raise 4 to the power of this denominator, if I raise 4 to the power of this 16, this is numerator, this is denominator. The upper side is numerator, the downside is denominator. If I raise 4 to the power of 2, I'll have 16. So that's how, because of these 2 here, as this one was 3, you look for a number that you raise to the power 3, that will give you 9. You raise to the power 3, also give you 16. It may not be the same number, but just a number you raise to the power of that denominator of the power that will give you that number inside the bracket. That's what I'm talking about. So let's go. Then everything raised to power. You will see why we are looking for raised to power 2. It is by 1 over 2. You see it? So from here now, these 2 will cancel out this and this. Since it's having this bracket, it means everything they are the same. So we just cancel everything. Or you use it to put the bracket, we affect this and this as well. So we are going to have 3 over 4. Very simple as that. So let's look at the next question. We're having 8 over 27 to the power minus 1 over 3. See, this one is not 3. See, the first one was 2, but this one is now 3. So what are we going to do now? The same thing. Look for a number you raise to power 3. I'll give you 8. Also, if you a number also raised to power 3, and we'll give you 27. That's what I'm looking for. But first, let's remove this minus sign. To remove that minus sign, look at what you do. Look at what you do. It's a very simple thing. Look at it. If you have A over B raised to power minus n, the same thing as B over A raised to power n. What you just do, just take the reciprocal of this inner fraction. Then the minus sign will go. So if I take the reciprocal of this now, everything here, it means you just turn this upside down. The denominator will move to numerator. Numerator will come to the denominator, something like this. 27 will go up, and 8 will come down. Then the minus sign disappears instantly at 3. So this will give us, so which number will go to raise to power 3 will give us 27. Which number will go to raise to power 3 and will give us 8, because this 3 here. So we raise 3 to power 3 to have 27. We raise the 2 to power 3 to have 8. So we bracket everything is power 1 over 3. So this 3 will cancel this, also cancel this, because of the bracket there. The final answer will now be 3 over 2, or 1.5, or one whole number. We divide this by this. For example, now look at it. We have 1, 2, 3. If we want to divide it by 2, we have 1, 2. That's already 1. We'll be left with 1 remainder 1. That's 1 remainder 1, or one whole number 1 over 2, or 3 over 2. Any of them is correct, or 1.5. Take note of that. So let's move to the next question. So we're having a cube times a square. This is simple enough. The answer will be a, because this and this are the same. Pick one of the base, and this is multiplication. Add up to power 3 plus 2. That will give us what? A raised to power 5. One is simple enough. So let's move to the last one. We're having 3a square raised to power minus 3 times 4a4. The first thing I'm going to do now is to remove this minus sign. Those minus above is not actually good. How do we remove it? Take reciprocal. See, this is over 1. Any number standing alone, let's say b. If you say number standing alone, let's say 5, it's always over 1. All the numbers are over 1. Like this a raised to power 5, that's over 1. All numbers are always over 1, because if you divide anything by 1, it will still be the same. So if you want to remove this sign now, that's why if you want to take the reciprocal of a whole number, it will be 1 over that number, because it was already divided by 1 before. So this one will move up, then this other numerator will come down. So we are going to have 1 over, I want to remove this minus sign, that's why I'm doing this, 3a square raised to power 3. The minus sign will go, times 4a4. Then the next thing, this 3 will open this bracket. So the 3 will affect this one, will be 1 raised to power 3. Then it will also affect this other 3, 3 raised to power 3. And it will also affect this one, a raised to power 2 raised to power 3. That will be equal to, okay, times 4a4. Take note of that. This 3 will affect this, this, and this. Everything there. So the next thing, 1 raised to power 3 is 1. 3 raised to power 3 is 27. A squared raised to power 3, look at it. A squared raised to power 3 will give us 3 times 2. You multiply the two powers. For example, now if you have something like this, let's say a raised to power m, every 3 raised to power n. What you do, you just multiply the two power. That's what you do. Just multiply the two power. If you have double power, you multiply the 2. It will now be 3 times 2. 3 times 2 give us what? 6. We have a raised to power 6 there. Times 4a4. So the next thing we are going to have now will be, we have a 1 over 27 a6 times 4a4. So this will give us, this will multiply this. 4a4 times 1, that's 4a4. Numerator will always multiply numerator. Remember, this is over 1. Any number standing is over 1. If you want to multiply, this will multiply this. Multiply this. But if it's division, you change to multiplication and take the reciprocal of this first before working. If it's addition or subtraction, you use the LCM method. That's how it is done. Take note. Then over 27 is 6. So the next thing, look at what we're having. We're having a raised to power 4 divided by a raised to power 6. Both of them have the same base. So what are we going to have? We're going to have 4 over 27. Then we have a, look at it, we have a raised to power 4 divided by a raised to power 6. So we can solve this out now as a raised to power 4 minus 6. Abi? It's possible now. A raised to power 4 divided by a raised to power 6. Remember division, if we have a raised to power 4 divided by a raised to power 6. Or you can also write it this way, a raised to power 4 divided by a raised to power 6 is the same thing. That will be a raised to power 4 minus 6. That's what I'm trying to do here. So it will give us 4 minus 6 is minus 2. So we're going to have 4a raised to power minus 6 over 27. Or we can also bring this down. I don't have it this way. Or you bring this down, we have 4 over 27. If you are bringing this across this sign will change to plus. If you move a number from numerator, to denominator, it will change sign. If you move a number from denominator to numerator, it will also change sign. Take note of that. It's very, very important. Very, very important in mathematics. So I'm going to have a. So that is a raised to power. This is a raised to power 2, not a raised to power 6. That will be a raised to power 2. So this is negative. If you break it down, it will change to positive. Look at what I'm trying to say. If I have something like this, let's say a square. And I want to write it as this a square over 1. If I want to write it as 1 over a square now, I'll have this one. If this one is going up, this one is supposed to be 1 raised to power minus 1. And 1 raised to power minus 1 is still 1. So that remains as 1. Then this one now will change to a raised to power. Remember, this 2 is positive, not change to negative. If I bring it back to the upper side again, the thing will change back to positive. That's how it is. If a number crosses division line, the power will change sign from negative to positive or from positive to negative. So take note of that. That's very important. So thank you.